Hello everyone, and welcome to my presentation. My name is Jeff Koss. I'm doing this presentation today in a class called Robot Navigation. I'm a student at the University of Advanced Technology where I study robotics and embedded systems. For today's assignment, I had to add a gyroscope to my robot, and I succeeded. So with Arduino, there are several libraries out there just for this specification, or just for this task, I should say, using the accelerometer basically that I'm using, which is the it is the MPU6050, and it's basically a 6-angle accelerometer. Acts like a gyroscope. You can get angles, you can get acceleration data, you can get position data. It's really neat in a very small package. I'm actually quite impressed with it. So let's just get right down to it. Basically, I enabled all of the functions, including the temperature sensor. And what I did here is I basically just used the header file that I use is the MPU6050 underscore TOCKN.H. I found this particular library to suit my needs perfectly, and you can actually graph angles with this. Believe it or not, I'm not going to get that in depth with it, but maybe in a later tutorial we can do that if we decide to build a quadcopter or something like that. So anyway, moving on, we assigned the gyroscope, and this is how we do it right here, MPU6050. And then we name it MPU6050, and we are using the wire header file. We're using wire to actually transmit the data is what we're doing here. So we have a long integer called timer, setting it to 0. And it's basically just going to store a variable right now as in time. So to set it up, you know, it's pretty simple, straightforward. We start the serial monitor at 9600 baud rate. I'm using the serial monitor because I do have some screens that I can use. I have, you know, a couple LCD screens. I have a couple of different ones I can use. But the problem is because of the construction of this robot, there's really no place to put it other than I'd have to modify something and rewire it to a. In other words, let's put it to you this way. This was a kit that was sent to me. I put it together, and it works. In order for me to add a visual monitor to this, I got to mess with it. I'm not sure if that's exactly the right thing to do right now, because if it messes up, I'm going to be out for the rest of the semester without a project car. So if that makes sense to you, great. If it doesn't, well, you know what? This is what I've got. So I'm using the serial monitor right now because I want to protect my valuable assets. Now, I will go ahead at a later date and add a monitor to this just to show you I can do it, but not right now. Maybe at the end of the semester. But right now, I just want to be able to prove that I can do this and do it right. In order to add the monitor, it's really not that hard. There's several libraries that I can use, and we just write a small little program that instead of writing it to the serial monitor, it's just going to write it to the monitor. No big deal, okay? So moving on, in the main loop, we start sending the data by calling update. So here's basically the guts of it. It's really simple, you know. We have the temperature. We have a function that's called get temperature. Basically, this library has a bunch of built-in functions already written in the library that we can just call. Easy peasy. Let me tell you, this is probably one of the easiest projects I've had to do, even though it looked kind of hard at first, you know. So here's what I got. I got temperature. We got acceleration on the x-axis. We got acceleration at the z and the y-axis. We have the gyroscopic position of x, y, and z. We have the acceleration angles of x and y. we have the gyroscopic angles of X, Y, and Z, and then we have the angles and the tangents for X, Y, and Z, basically. Or we have the angles for X, Y, and Z. So it's pretty simple. Not really that much to it. I'm actually going to run this alone right now without the other code because, well, to be honest with you, I can't really put this on the floor and drive it around right now because I have to use the serial monitor, which means that it's tethered to my computer, and this thing runs pretty fast, so I don't want it to basically drive off with my computer deck, you know. So I will show you that I'm tilting the car and stuff like that, but let's take a look right now at the serial monitor. I have it all hooked up right now. So what's going to happen here is it's going to calculate the offsets. What this is doing is it's zeroing out the gyroscope so it gets a correct reading. As you can see at the beginning, there was a X value. It was off a little bit. It's on a little bit of an incline. Okay, so here's what's going on here. What do I have it at here? I think every second or so, it's going to update with the information that we have. I'd slow down right now because otherwise, if I sped it up, you wouldn't be able to see what's going on. To me, it's still kind of too fast for a presentation, but I did want to kind of keep it realistic. So here we go. We have temperature in Celsius. You have your acceleration right now, basically nothing. Your gyroscopic angles are going to be basically nothing. Your acceleration angles are going to be basically nothing. Your gyroscopic angles are going to be nothing. And your angles are going to be set at where the car is facing right now. So in other words, this can get the X, Y, and Z position relative to how the sensor was set up. So let's take a look here. I'm gonna move this around on the y-axis, which is going to be roll. So we're going to move it to the left. We're going to bank left, and it should give you a negative reading, and it does. Negative 64.22.06. We're going to go back to the zero position, or as close as possible. Okay, and then we're going to bank to the right, and we get a positive number. So how this works basically is zeros in the middle. Anything negative is going to be on the left side. Anything on the right is going to be banking to the right side. The only way I can kind of describe it to you is if you're an aviation buff or you worked in aviation, you'll know what a datum line is. So datum is basically zero. Anything off to the left is going to be a minus number. Anything off to the right is going to be a positive number. Okay, so let's do the x-axis, which is going to be your pitch. We're going to pitch up. I should get a positive number, positive 30. We're looking at the very bottom of the information where it says angle X. We're going to go back to zero. We're close to it. Now we're going to dip down and do a dive. Negative 41. Okay, this is the cool part right here. Angle Z is your Z-axis. This is your yaw. So we're going to yaw to the right. Okay, we're going to yaw to the left. Notice how it's different like that? I just noticed that myself. Let's see something here. Let me see if I can get the zero position here. No, that's too fast. That's too much. Okay. Okay, so we're right about there. So if I press right rudder and we go to the right, yeah, it's a negative number on the z-axis. If we press the left rudder and we yaw to the left, it's a positive number. So that's inverted for some reason. This bears more investigation, doesn't it? So I have to look into that, why it's doing that. Let's try to get some acceleration going here. I know I don't have the car running, but I can kind of simulate it. If we can see what's going on the y-axis, you can see it. It's I'm kind of moving it back and forth, you know, and you're getting different readings from there. Let's go with there you go. So yeah, we're getting incremental updates, here and there for that. So let me show you what it looks like. Let me hold the robot up and stuff like that here. Give me a moment. I'm going to turn my other camera on and we'll go from there. So, but thank you very much, guys. I do appreciate it. Okay guys, so here's my robot car. Here's the gyroscope right here, or the accelerometer. As you can see, I have it tethered right now because we're using the serial monitor. But as you can see here, there's really no place to put it. I mean, I'd have to probably solder it onto here, but I'd have to go through everything and make sure that the pins that are being used aren't going to interfere with what we're doing. I've only got three possibilities. UART, the SPI bus, or the I2C bus. I'm thinking I2C, but for now, we're just going to do the serial monitor. So let's take a look here. Okay, so here's the car. Here's the serial monitor. I'm sorry, but this is about the best I can get right now with a handheld phone. So if we bank, you can see that it gets a negative number on the Y. If we bank the other way, positive. Pitch works, rotating around the Z-axis works. And let's see if I'm going to basically move the car around. Let's see if we can get the numbers on the accelerometer to go up. Oh yeah, they're changing a little bit here and there. Yeah, look at that. See, they're changing. So it works. It works. And I probably could get it a little bit more sensitive. Right now I have the setting to 3, which is kind of like in the middle. But yeah, it works. So everything is good. All right, so that's the end of my assignment. Thank you very much. Bye-bye.